The Arctic is seeing a rapid decline in sea ice even during the cold winter months when it should be recovering from the summer melt. Scientists say that one often overlooked factor is playing a bigger role than previously thought: atmospheric rivers. These long, narrow bands of moisture in the atmosphere transport warm air and water vapor from the tropics. They can extend for thousands of miles and dump rain and snow when they make landfall. In January, atmospheric rivers brought a parade of deadly storms that unleashed heavy rain, flooding and mudslides in California. REALTED, before and after, Lake Oroville, California's second-largest reservoir, has risen 182 feet. Now they are increasingly reaching the Arctic, according to a study by a team led by Penn State University scientists and published Monday in the journal Nature Climate Change. Using satellite observations and climate models, the scientists found that atmospheric rivers are reaching the Arctic more frequently during the winter season, especially over the Barents-Kara Seas, off the north coasts of Norway and Russia. The authors used satellite images to analyze sea ice immediately following the atmospheric river storms and discovered sea ice retreated for up to 10 days. In winter, temperatures in the Arctic are below freezing and the ice should be recovering. Instead, these powerful storms are slowing down seasonal ice recovery. The storms can be blamed for a third of the Arctic's wintertime sea ice loss, the scientists reported. Arctic sea ice decline is among the most obvious evidence of global warming from the past several decades, Pengfei Zhang, the study's lead author and assistant research professor of atmospheric. Despite temperatures in the Arctic being well below freezing, sea ice decline in winter is still very significant. And our research shows atmospheric rivers are one factor in understanding why. Atmospheric rivers are inherently warmer than the surrounding Arctic environment and can act like a blanket, trapping heat near the Earth's surface and preventing it from escaping out to space. Their heavy rainfall also has a melting effect, especially on fragile, regrowing ice. Climate change is amplifying the intensity of atmospheric rivers, scientists say, as a warmer atmosphere is able to hold more moisture, leading to heavier rainfall when they make landfall. Using climate modeling, the study also found evidence that global warming is one factor in the increased rate of atmospheric river storms in the Arctic. The Arctic, which is warming up to 4 times faster than the rest of the planet, has undergone dramatic changes in recent decades. Last year, in its annual Arctic Health Checkup, scientists with the National Oceanic and Atmospheric Administration found it has become hotter, rainier and wetter, with a rapid decline in snow cover and unprecedented late-season melting.